Alright, we'll see how long this battery lasts, and yeah, I figured I'll do this the old-fashioned crappy way. I've made 4,000 YouTube videos, so I might as well do this in a YouTube video. Might as well. Yes, I plan on revolutionary, changing all of physics and the whole perception. They have got it all wrong, and yep, yeah, I've got it right. Anyway, a big little good chunk of whatever. I mean, big changes, radical change. It's a radical change, trust me. A year from now, yeah, the whole conversation's going to change. So yeah, and I'm going to do it with a crappy YouTube video. And it just seems perfectly consistent with what my existence does. So let's begin, right? So you're here. You're going to hear it first. Okay? Well, probably, unless you're looking at this video like a year from now. But anyway, you're going to hear it first, sort of, kind of. You heard it here first. Well, maybe you didn't, because, yeah, again, this video will be up for a while. Anyway, I figure I can do it this way, and then I can get some people make their little snarky comments and make their critiques and say, that can't be right, and I'll explain why, and that'll just help improve how I have to explain this so people can understand it. Alright, so number one principle. Number one new rule for describing reality. Yeah, material reality. All matter, including its atomic particles, is made of photons, still moving at the speed of light. So you can call them photons, you can call them quanta, it doesn't really matter, but we've got that whole electromagnetic spectrum thing. And there might be stuff at the other end, and there might be stuff at that other end that we haven't quite discovered yet. And that's part of this explanation, I think. But regardless, we have these things moving at the speed of light. So everything is made of things moving at the speed of light. They're just caught in configurations that make them appear like matter. So physical matter, I'm just a bunch of photons trapped in orbits. And but that's all there are. There's just little things moving at the speed of light. So everything fundamentally is moving at the speed of light at its core, at the universe's core. If you look at it like on the scale of the universe, everything's moving at the speed of light, and there is nothing else but stuff moving at the speed of light, just caught in patterns. Still moving at the speed of light, so that's the important. Matter is effectively non-directional energy when the photons that comprise it are in a net directional balance. So the point is my photons, some are going that way, some are going that way, some are going this way, some are going that way, some are that way, some are that way. But the point is that they're all collected together, seem to not be going in any direction. So their pressure is balanced. That's why I'm not moving anywhere. I'm not going anywhere. You know, my arm's moving because the pressure balance changes for my hand. So it gains some movement and then it stops again. Okay, but that's again photons, more photons. When I go from here to here, what happened is the photons in my hand, yeah, more of them went that way. More of them went that way, then went that way, or that way, or that way, or that way, or that way. Get it? Yeah, I think you can get that. Real movement is absolute, although difficult to detect. So the relativity thing, yeah, okay, Einstein, you were really smart, but no, it's absolute. It's just that we can't detect absolute movement easily because we always have to compare it to something absolutely moving, which would be something like a photon. So we'd have to compare its movement to something that is absolutely moving, like a photon, and photons are really hard to know exactly where they are. That's the whole problem. We can't detect where they are. So yeah, it's sort of difficult to do, and our movement is so slow by comparison that quite obviously it's very hard to see our absolute movement when we're absolutely moving so incredibly slowly compared to a photon. But we are absolute. There is absolute movement. There's no relativity. No. It's all absolute. Individual photons do not interact with individual photons. So this is the important thing to understand. So let's just understand. Let's say a photon is this little simple thing. Pen. Okay, so you got this simple thing, and let's say it can get, I'm going to say like for things things like electrons. Well, let's just say that this is a cosmic ray, and then a radio wave might be a string of these photons all tied together this way, so they can connect to each other. But the point is if they intersect each other, if two photons come into each other, so we have two of them here, this one's moving this way and this one's moving that way, they'll essentially just go right through each other. This one's momentum will go right through that one's, and this one's will go right through that one. So even if they're in a configuration of a big blob of stuff, and so you have a radio wave interacts with a light wave, you know, that's only like 3 of these things, it just goes right through it, kind of a thing. So that's the idea in principle. But you just need to understand, for the sake of the argument, that this is the reason why you need matter. You need photons trapped for photons to interact with photons. So photons can only interact with each other when they're caught in material traps. Yeah, like electrons. All right, so photons do not interact with number 3. Photons do interact with electrons and can transfer some portion of their directional momentum, information, energy. So what I'm saying is they transfer, if they're trapped, if they terminate inside of a piece of matter, then their momentum, their direction they were going in, is going to be reflected in the overall pressure inside the matter. So the balance is now a net balance, 1 photon in that direction, kind of a thing. So but it's kind of, direction is kind of just information. It's not really energy, because all photons have movement. They can just move in any direction. So where they go isn't a reflection of their energy, and you can change their direction without exerting or using any energy. So the real catch here is that their direction doesn't require any energy to change, but the fact that they have momentum in a direction is true. They have energy, and it's in a direction, which is momentum. Alright, that's a little bit technical, but I think people who know something about physics understand the difference between momentum and information. Maybe. Well, energy and information. They're 2 different things. Okay, anyway. 4, this is a big one. The quantum mechanical effect is created by the condition of electrons. So quantum mechanics is completely and entirely a description of the function of electrons. It is not a description of photons. It's a description of photons in the configuration of electrons. All the complexity, all the wave function, all the probabilisticness, all of that comes from the fact that electrons can have very unique position, distortion, eccentricities. All electrons are not equal, and that's why all effects of interaction between photons and electrons are not the same. So all QM complexity in the behavior of photons is a reflection of the complexity of the electrons they interact with. So the 2-slit experiment is not about the photon, it's about the electrons that make up the slits. It's about the electrons that made up the little hole they shot the photons or electrons through. And of course, when you're using electrons in the 2-slit experiment, it's electron on electron, which is double electron interference. So that's quite obviously an electron phenomenon, not a photon phenomenon. But anyway, the current perspective is that photons are carrying the magic, that photons have something to do with quantum mechanics, and photons are just a victim of the circumstance of the complexity of electrons, and the photon must interact with an electron to create any quantum mechanical effect. It's entirely an electron phenomenon, and so this is a fundamental change in how physics describes the circumstance currently. Alright, there is no uncertainty principle or rule beyond the fact that you cannot build a scale small enough to weigh the smallest things. So this is just kind of this argument about position and momentum. Yes, you can't measure these things on the smallest things because there's no scale to measure them on. You need something smaller to measure something bigger. It's just a fact. And so photons have absolute position and momentum. Okay, so I'm just verifying that photons carry no quantum mechanical effect. They only carry the effect in the sense that their position and momentum is changed by interaction with electrons, but they have an absolute position, they have an absolute direction, and they are not at all in any vague cloud of uncertainty. That's a metaphor. It's a way of mathematically dealing with the fact that you can't establish position and momentum exactly, but it has nothing to do with the reality. The reality is there is an absolute position and an absolute momentum, and there's just no doubt about that. It's just a fact. Okay, 6. All movement in atoms, matter is created by eccentricity in their shape. So to understand that when matter moves, what's happening is that the atoms inside of whatever's moving have actually changed their configuration, so the electrons are in net moving, more photons are moving this way than are moving that way, and so there's a change in the net balance of the movement of the things moving the speed of light. So it's like the school of fish argument. For my hand to move, the school of fish is all swirly when it's still, and then the school gets a little less swirly as it moves. So that's how the movement is accomplished, is the atoms have to get less swirly in the direction of the movement. And that's what happens through our musculature and the chemistry of our biology, is it actually changes the atomic structure of our hand, which allows it to be moved by gravitational forces, but I won't explain all that yet. Alright, so distortion in the spin or orbit of the electron. So so it's just, I'm just saying that you're changing the net pressure of the direction of the total amount of the photons in the thing that's moving when it's moving. So it's a change in net photonic pressure, that's how I'm calling it. That's my coined phrase. It'll be photonic pressure, I suppose. Somebody must have said that by now. Alright, there's two little draft elements I added here, which are it doesn't really matter how you model these things, but this is one way of modeling them. Electrons are a string of photons arranged in a double helix configuration, which creates opportunity for spin to create variable speed. So I've sort of pointed this out before, but if we take these little building blocks and we say they stick to each other, plus minus sides, and we have an arrangement of them, that what can happen is they can spin on that arrangement, and so absorb more space. So if they're spinning, if this one's flipping over this way and this one's flipping over that way, as they're moving, they will eat more checkerboards of, let's say, potential space is out here. They'll eat more space in these turning directions rather than eating space in this direction. So their speed will be slowed down because they're turning as they're moving. And so you can really see that in a double helix. The point being is that you could spin this, and that would change the forward direction speed based on how fast this thing spins. But it could be that there's no space between this helix, that this helix is just made of photons next to each other. And what I'm speculating is happening, so just think of these as a bunch of little dominoes, is that when a photon comes in, hits an electron, it knocks out a piece of the exact size or similar size to what it came in, gets knocked out, and it reflects off the nucleus, let's say, comes back, also bounces back into this helix, and pops out a new piece. So the new piece might be a different size, so you have a different wavelength, depending on the turning of the helix and all kinds of other circumstances. But this is how you could have one form of light goes in, one form of light comes out, that kind of thing. There is no true reflection, so this I've just made up this bouncing off the nucleus part. This would be explained as some other phenomenon like the the piece flies off of here and it hits some other electron somewhere else, and position has changed because it shoots it out at a different place because it moved in the time period of the transition. So as it's bouncing around, more time is absorbed, and therefore the position of electrons is changing, and therefore it will be reflected at a different time, and it's time that really changes that creates the illusion of reflection. It's the fact that time passed between the point it went in and the point it goes out, and in that time that passed is reflected in the angle of deflection. So the new emitted photon has been emitted later, and that accounts for the difference in the angle. But that's more geometry. I know this video isn't intended to do all the complex stuff. It's just to give this outline that this is what it's made out of. There's no forces, there's just connection. So what I'm even saying is that the north-south idea, the magnetic connection between photons, could actually be hooks of some kind, bars, where they actually fit into each other like puzzle pieces. That all of what this is basically saying is that it seems quite possible that there is no force in any matter, that all the matter creates structure, and that the structure holds it together. So like there is an actual string that holds the electron to the neutrons or proton, and that the string holds the neutrons together with the two neutrons together. That things are actually held together by physical pieces of photons. Photons hold all of this is made out of little blocks, and the little blocks are connected to each other. There's no forces, there's just connections. It's all quite mechanical. So in a sense, this new description of physics eliminates the idea of forces. Are fields. Fields are actual densities of photons. And let's remember, photons are not just light. Photons are gamma rays, X-rays, microwaves, radio waves, the whole big pile of different kinds of configurations of photons. Alright, anyway. So the other draft thing is electrons captured by atoms have an open ring-like shape that provides the opportunity for them to be interlocked and effectively consume space in the direction of their wider orbit. So part of the argument making, so this double helix, when it's in an atom, so here's an atom's nucleus, and when this thing's in the atom, I'm speculating that what electrons do is overlap a little. And that overlap provides the opportunity for not only for them to be interconnected, in the sense that they can overlap into each other and then be bound to each other, but it also provides this circumstance where they will consume space in this direction. So they will be constantly tending to move in the direction of this opening. So they will constantly be eating space. So any eccentricity in this orbit, so if this orbit's perfect, then they just keep eating a little bit of space evenly around the whole circle. You can sort of understand that. But if I change the shape of the orbit, you could understand that now they're going to be eating space, less space in this direction than they'll be eating in this direction, because they're going to have a wider orbit in this direction. So they're going to eat more space in the direction of any lengthening or stretching in their, because they're always moving the speed of light. See, they can't change their speed. They're always moving the speed of light. So any change in the orbit shape will change directionally which way this electron would be moving. You can sort of get that, right? I don't know if I need to go into that too deep. But anyway, yeah, it's one way of explaining the eating of the space, so to speak, that creates movement. But it will be explained in another way here also. Alright, specific types of photonic pressure can only be... Oh, that's no. I'm supposed to do 8 and 9, 7 and 8 first. Alright, okay. Consume space in their wider orbit. Right, I did that. Okay, 7. Photons exert directional pressure on any system they terminally enter. So that's sort of explained before, but if a photon goes in a direction and it doesn't, no energy comes back out, then that directional energy will have its effect on the overall system in terms of creating the net, changing the net pressure. Changes in the internal net photonic pressure causes material objects to move or acquire arrangement momentum. See, this could also be talked about in the sense that, see 7 and 8 are so related, it's hard to, I'll wait till I get to 8. Acquire momentum in the direction of the greater photonic pressure. So again, it's about this photonic pressure thing, and whether it's an internal phenomenon or an external phenomenon. Alright, so here's number 8's the big one. The universe exerts an evenly distributed photonic pressure. Proportional to their mass, material objects can shield other material objects from that pressure and create gravitational attraction. I mean, that's just it's huge. And this is something that Feynman had talked about in one of his lectures, and he dismissed it because of this shape problem. I don't think he realized, if he would have understood that matter was made out of photons already moving the speed of light, he would have understood that the momentum problem isn't a problem. That momentum is quite irrelevant on the universe's scale. On the scale of the checkerboard, momentum is an illusion. The photons are still moving the speed of light. There is no such thing as momentum. There's just photons moving the speed of light, and there's either more of them moving in one direction or more of them moving in another. So it's kind of like the school of fish argument again. It's not about how many fish. It's about how the fish, what the fish are doing. If the fish are swirling in a swirl, then they're not going anywhere. But if they're all going in one direction, then they're going in one direction. The whole school moves, and that's what matter's doing. So it's the atoms moving, and that changes. Any illusion of momentum is just an illusion of direction. It means that more of the stuff is pointed at you. More of the photons are coming right at you. And as pointed out earlier, number 2, photons go right through each other. So the ones pointed right at you are irrelevant. The only ones that mean anything, are the ones that you can hook into your system, that get stuck in your system. So anyway, so the idea is that gravity works this way. So here's 2 objects. There's a constant pressure coming from the universe. It's pushing on all these things. And what happens is that pressure gets eaten up by matter, by things with atomic weight. And so this object would be shielded from the pressure. So it has pressure from all these directions except this directions. The direction's now blocked here. And that's what's pushing the objects together, is that we have now changed this photonic pressure, and this object is now going to be attracted to this object, and likewise this object has been shielded by this object, and it's going to attract that object. And anyway, this works perfectly, and the only thing that changed it was this idea that if this thing had momentum, that it would be getting more pressure in one direction than in another direction. And that is solved by this simple arrangement issue. That if more of the photons are moving in a specific direction, so here's your school of fish idea, and if more of them are moving in a direction, that's going to mean that less of this pressure is going to be effective. Okay, because more of the fish are coming right at you, this pressure is not going to be as strong, and the pressure from behind is still going to be the same pressure from behind. So it's not like this pressure got greater, it's just that this pressure got lesser, and so it balances out again, and so the only thing left over is the momentum of the thing, and there is no resistance created by the new pressure, because you're essentially gaining mass as you move, but it's not technically real mass. It's only an illusion of mass based on the fact that you are having more of the photons directly pointed at you. So anyway, it's perfectly explainable. It's just disappointing that people like Feynman couldn't give it a chance to figure it out. It works for every part of gravity. This idea of photonic pressure works to explain all of it, and they threw it out for a very small reason. A reason you could explain with some sort of explanation, and they didn't. It seems they didn't try to explain it. So anyway, it also works for magnetism. That's number 9. Specific types of photonic pressure can only be blocked by specific atomic structure, magnetism. So we know that certain atoms are capable of creating this thing called magnetism. And the simplest argument is that there's a ton of this photonic pressure, but some of it goes right through all matter. Like some of it just goes right through it. It doesn't have any effect on it at all. But certain atoms, it is sensitive to. So certain atoms are sensitive to that certain kinds of rays of photonic pressure. Certain photons they are going to capture. And so that's what happens in magnetism, is that you have the same effect as gravity, the same the same basic idea of shielding the pressure of a specific kind of photon. So a specific kind of photon is creating magnetism. And it's basically the same kind of effect, is that where it shields it, it will create negative pressure, and that negative pressure will attract things, and where it doesn't shield it, it will create the inverse of more pressure now will be affecting that thing, because you've changed the pressure dynamic. So when you say, if you move all the electrons in an object from this end to this end, you change the structure of the steel or whatever, because now it's got a ton of electrons over here. You've basically changed the shape of the atoms in the other end. And by changing their shape, you're going to make them more susceptible to this photonic pressure. And that creates the idea of magnets repulsing and attracting. And I could go through more explanation, but you can really get it if you just think about it. It's just a blocking or a releasing of the external pressure. Alright, I think, I did it in the one video. I thought I might take more. These are lousy drawings. I think there's different ways like I said, some of this stuff I'm just going to call draft. Like I said, speculating about the double helix of the electron. I think it makes sense because it accounts for the fact that electrons can move at variable speed. I think the idea of the hook of the orbit is infinitely sensible, and the idea that it hooks into each other and that's what's holding electrons together is this ring idea. Let's see what else. But yeah, there's a lot of the whole idea of understanding exactly what the difference is between a radio wave photon and a gamma ray photon. Understanding whether that means there's more photons or whether they're arranged in some specific way. It also, polarization is also you sort of get an indication for polarization if you do understand, like say a cosmic ray was just one block and a radio wave was like 500 blocks of photon. Then you could figure that visible light would be somewhere in the middle, and that it would definitely have a shape in the sense that it would have a width, and that width could be in different directions. But all these photons are just associated with each other. They're all moving exactly in the same direction. They obviously can't be spinning, because if they did spin, that would slow them down. Yeah. So that's the difference between a photon and an electron, is this idea that an electron is basically a stream of these that are spinning and twisting as they spin. So it's a length of photons twisted like a ribbon. And how twisted the ribbon is will dictate how tight the twists are, will dictate how fast the electron moves. Okay, so yeah, so I'm working on now the write-up for each one of these bullet point type points. But I mean, the big one is that all matter, okay, is made up of these photons moving at the speed of light. That's the game. That's the game we're in. It's all just light. It's all just photons moving the speed of photons. Yeah, I guess we have to change this language a little. I like the idea of just calling all the photons light. And it's just the difference between visible light and invisible light. That sort of gives you an indication of what's going on. But clearly you can see in the world that if photons were able to hit each other and interact with each other, there would be all this noise of interaction. All the photons would be reflecting all over the place. And the only time that happens is when there's an atmosphere and it's full of electrons. And so the photons are hitting electrons and creating visible noise. So anyway, but that's a real easy thing to explain. Yeah, and the other big one is this quantum mechanical effect is created by the condition of electrons. It's all electrons. Quantum mechanics is a description of the behavior of electrons, not the behavior of photons. So I think I've done my job. Till next time. Begin now. Revolution time. Begin it. Yeah, you can start now. Yeah. Bang. I just fired the gun. Start. Revolution now.